All right, so logarithms and exponentials, that's what we're doing.
No, he got a pass.
Oh, okay. Logarithms and exponentials are inverses. That word inverses means that they are opposites in every way. So let's talk about opposites here. What is the opposite of domain? Range. So what's the opposite of x values? Y values. Good. I want you guys to write this down somewhere at the top of your paper. Okay, in terms of what we're learning now, we have, let's see if I can move this over. All right, I have exponentials. What's the opposite of an exponential? We're going to learn that today. It's a log. The log is the opposite of exponential. What kind of asymptote do I have for exponential functions? Horizontal or vertical?
Horizontal.
Horizontal, that's what we did last class, horizontal. So the logs have what?
Vertical.
The way that I remember it, and you do not have to do it this way, but it helps me. If I'm thinking about asymptotes and which one goes together, I think about LV. Okay, what does that symbol look like? Think about fashion. Louis Vuitton, good. So I think about Louis Vuitton, log, vertical. Okay, because I don't want you to get confused to think that vertical goes with exponential. Vertical has to go with log, so therefore horizontal has to go with exponential. Okay, so if you get stuck, think about LV. All right, grab your calculators. Once again, as I'm typing this in, I want you guys to type it in, because if you sit there and just watch me do it, then you can't do it on your own. Before we type this in though, is this going to be an exponential graph or a log? Do you see the word log anywhere?
Yeah.
Where?
Oh,
This is an exponential, right? There's an x in the exponent.
someone pressed that.
Oh, sorry. So it's an exponential graph. So if it's an exponential, what kind of asymptote will I have? What did we just talk about?
Did you say vertical? Horizontal.
Okay, yeah, vertical goes with the L, LV, right? This is exponential, so this is horizontal. The reason we need to know that is because, you see how it just says asymptote? It's not asking you horizontal or vertical. You have to know that. So I know if it's going to be horizontal, would that be x equals or y equals? Horizontal? You guys are killing me today. Isn't it a long day? A long week? You know, it's Tuesday?
Yeah.
Alright, type this into your calculator. And your y equals, you have 10 to the power of x. And then I want you to graph it. Let's see what it looks like. Alright, sounds good? Looks good? I'm going to go to my table. I'm going to find something really easy that I can plot. Alright, I'm going to do 0, 1, and 110. 0, 1, and 110. For these graphs, I've said it before, but just so you guys know, I'm more concerned that you're putting your dotted line for your asymptote than I am with how perfect your graph is. Your graph does not have to be perfect. You can just sketch it. In this case, my asymptote is what? For exponentials, I look for the number after my exponent. Is there a number there?
No,
No, so I can assume it is going to be plus 0. So my asymptote is going to be y equals 0, which will be here. There's my dotted line. Make sure you're putting your dotted line, and make sure that you are like emphasizing it so I know it's there. And then let's plot these points. Regardless of where our asymptote is, we're always going to plot based on our origin, 0, 0. So I go to 0, 1, which is right there, and then 110. Okay. I'm going to check back with my graph just so I can make sure I'm sketching it right. Okay. So I'm going to just sketch my graph. It does not have to be perfect. Get a couple of easy points. You don't have to graph all your decimals. But it also, like, some of these graphs sometimes looks like this. Does that make sense? No. Like, some of them look like you guys just made something up. Make sure that it looks very similar to what we're doing. Don't just kind of scribble it. All right, my domain is from left to right. From left to right, how far am I going? All the way, forever and ever. So negative infinity to positive infinity. My range is from down to up. So from down to up, I start from the bottom. Where does my graph start? At 0, which is my asymptote. And I'm going up to where? Infinity. Okay, increasing and decreasing variables, or intervals, sorry. Always go from left to right. From left to right, am I increasing or am I decreasing? I'm increasing the whole time, right? So because I'm not decreasing, I just went on and wrote none. I'm not decreasing at all. I'm increasing from negative infinity to positive infinity the whole time. I'm increasing. You messed that up on your quiz?
Yeah.
Well, the good thing is it's just a quiz, so I'll highlight it, I'll give it back to you. Alright, my y-intercept, that is where x is 0 in your table. My y-intercept is going to be 0, 1. That's where I'm crossing the y-axis. Alright, your zeros here, which also means your x-intercept. Okay, your x-intercept, that's the opposite. That means I need to know where y is 0. Look in your table, is y 0 anywhere? No. So that means I don't have one. And I know why I don't have one. It's because I have an asymptote there. I can't touch the asymptote. Alright, now my end behavior. This is my left arm, the second one is my right arm. My left hand here is going to keep going on and on, closer to the asymptote, which is, careful, close to the asymptote, which is 0. Remember, it's not actually touching it, it just gets closer to the asymptote. And then my other arm that's going up here is going higher and higher towards where? Positive infinity. Any questions there? Nope. All right, good. Let's look at number 2. Before we get started, is this a log or exponential? A log. I know it's a log because it says log, right? Jeffrey, will this be a horizontal asymptote or vertical? Vertical, because I know that my LV goes together, so I need a vertical asymptote, which means I can go ahead and write x equals. I know vertical is my x values. All right, let's grab your calculators. Everyone take this in. Your log is right next to 7. When you press log, your parentheses should come up automatically. That tells you that something has to go in there. Whatever's next will be in your parentheses. So we have log of x. When you graph it, it looks a little weird. It looks like it just stops there. It doesn't. It keeps going all the way down here. For whatever reason, our calculator won't show that, but that's okay. We'll draw it out. So let's go second graph and get some points. All right, do you guys see where this error is starting? Okay. That error is also your vertical asymptote. Okay, wherever your errors start is your vertical asymptote. So my VA is going to be what? 0. Good. I'll show you a different way in a little bit. But for now, this is probably the quickest and easiest way. And once again, you don't have to graph a million things. You can just look at this. Make this a little smaller. Okay. All right, so if you look at the table here, my vertical asymptote is here. So my vertical asymptote is 0. Okay. I am going to graph points for, and I'm only going to pick 1 or 2 of the easy ones. I'm going to do 1, 0, and 10, 1. I don't care about those decimals. Alright, so my vertical asymptote is at 0, so I'm going to draw a vertical line right down 0. This is why it's important to know whether you have a vertical asymptote or a horizontal asymptote. I don't want you to draw a horizontal for a log. And now let's plot the points. 1, 0 is there. 10, 1 is a little bit off the grid, but that's okay. So my graph is going to look like this. And then we just keep going down. That's what it looks like. Just graph a couple points, that's fine. Alright, my domain is from left to right. From left to right, how far left do I go? When does my graph start? There, right? It starts at my vertical asymptote, which is 0, and it keeps going on and on towards positive infinity. This is what's different about exponentials and logs, because with exponentials, your domain was negative infinity to positive infinity. Now your range for logs is going to be negative infinity to positive infinity, because if you look at your graph, how far down to up are you going? Well, I'm coming from a negative sign, and I'm going all the way up to a positive. All right, increasing interval. Always start left to right. Are we increasing or decreasing? Huh? We're increasing, so I can go ahead and write 9. I know I'm not decreasing. And I'm increasing the entire time from negative infinity to positive infinity. All right, your y-intercept means where is x 0? Well, it says error beside it, right? That's an asymptote, so we can just write none. It doesn't cross the y-axis. My zeros means where does my 0 in the y column, basically. So that would be 1, 0. Right? You have to know that y-intercept and x-intercept are basically opposites. If you're using your table for x-intercept, you want to see where is y 0. That's where it's crossing the x-axis. And then as x approaches positive infinity, so it's this guy over here, this right one. As x approaches positive infinity, I'm going towards positive infinity, not 0. Eric, I'm just going to keep going on and on and on. There's no 0 out there. This one would be towards 0 because that's your asymptote.
Oh,
So when we go towards our asymptote, we use that number. When we go towards the open space, it's going to be infinity. Okay? All right, turn the page. Jeremy, you'll be able to catch up. So far, we did one graph like last class, maybe did one new one. We'll do the other new one again.
Oh, she's not. I was going to tell Ms. Mitchell I didn't want to pay overtime to the security policeman protecting her money. So I was bringing it back to her, so.
I'll let her know it's
Yeah,
there.
I just couldn't afford the rent-a-cop that much longer to protect that amount of money.
All right, take a look at these transformations. Guys, we've done transformations since unit 1. Hopefully we can just spit these out. My first number that's in front of my log can tell me 3 things. It can be reflected, or, well, I just told you one. If it's a negative, it's reflected. What else can it tell me? Yep, or stretch. If it's bigger than 1, we stretch. If it's smaller than 1, we compress. I want you guys to circle this B down here and just write the word base. And we'll need to know that eventually. That's our base. If the base is, if there's nothing there, it's understood to just be 10. Any questions so far on what my A tells me and my base? Okay. If I look inside my parentheses, what does this negative H tell me to do?
Go right.
Go right or left. Good. All right, and then my last number back here tells me what? Up or down. All right, and vertical asymptote. This part is important because you may have to memorize this, which means you have to study it. Your vertical asymptote, you can know what it is because it is x is equal to h. So that's a major difference. So we have exponential graphs, our exponent or our asymptote is that last number, right? When we have logs, my asymptote is the opposite of what's inside here. What's inside the parentheses? Just the opposite number. Your domain for logs, you're going to have your asymptote to positive infinity or negative infinity to your asymptote. Because we're going left to right and we have a vertical asymptote. And my range is going to be all real numbers, which is negative infinity to positive infinity. Any questions on my transformations? Hopefully we remember those and we study the positioning of things so we know how to describe our graph. All right, perfect example. I have transformations from y is equal to log of x. So in letter A, I have a negative and then I have a +3. What does that negative tell me to do? To reflect. And what does that +3 tell me to do? Go left. Good. Anything inside the parentheses with my x is telling me left or right. It tells me how to shift horizontally or horizontally. Look at letter B and be careful. I have 1/3 and then +1. Now before you answer, What this problem is essentially saying is y equals 1/3 times log of x plus 0 plus 1, right? So most people are yelling out left 1 because you see that it's close to my x, but is it in parentheses? No, so that means that it's just behind it. Because we don't have to put this plus 0 in parentheses, it's kind of just understood, right? If you see x by itself, you just have to imagine that really means x plus 0. So I have 2 transformations here. What's the first one? We're going to compress by 1/3. And then we are going to do what? No. Well, left 0, but we don't have to say that, right? Left 0 means we're not moving. And then we're going to go up 1. Alright, in letter B, I have 3/2 plus 2 minus 1. So I have 3 transformations. What are they? Good. We're going to stretch. Everyone's been yelling out compress because they see a fraction. But that fraction is bigger than 1. It's 3/2. So anything bigger than 1, we stretch. Okay. And then my plus 2. Good. And then minus 1. Beautiful. Down 1. All right. Let's look at number 1. It's a log graph, right? Because it's a log, do I have a vertical asymptote or a horizontal asymptote? Vertical asymptote. So I'm thinking about my LDs. So that tells me I have x equals. Okay, notice how there's no parentheses, right? So this equation is really y equals log times x plus 0 plus 1. So my asymptote is going to be the opposite of what's inside my parentheses. So what's my asymptote? It's just 0. What's the transformation here? Nuh-uh. At the very end is up. You're looking at inside the parentheses. When you put this in your calculator, it is important to know that when you start typing in, just say we type in log, your parentheses comes up. You have to put something in there. So just log of x, or you could put x plus 0, doesn't matter. Plus 1 is not in parentheses, so you have to keep it that way. If you put it inside the parentheses, then it's going to change your whole answer. Now let's graph it. That's what it should look like. I'm going to get a couple of easy points. Can we tell from my errors what's my vertical asymptote? What's the first one?
1, 1.
What's the first error?
0.
0, right? So that is my asymptote. All right, I'm going to graph 1, 1, and I'm going to leave it there. I don't think I need more than that. My vertical asymptote is 0. And I'm going to graph 1, 1. You can graph more than that if you like. Or you can just sketch your graph. Good enough for me. My domain from left to right. If I go left to right, my graph starts where? No, what's my asymptote? It's 0. And I keep going left or right towards positive infinity. And my range is going to be all real numbers. Because it's going to keep going down and up the whole time. Any questions there? All right, I'm going to do this one with you guys, number 3. Notice how number 3 is on the very back page. Number 3 is an ln. ln is still a log. Okay, so we're going to treat ln's just like log with a different base. Okay, so if I know it's a log, what kind of asymptote do I have? A vertical one. Good. And it tells you there too, vertical asymptote. So I'm going to have an x equals, okay? What's the opposite of what's inside my parentheses? Good, -2. But let's just say that you forgot that on your test. That's fine. Let's grab our calculators. Go to y equals. Now let's type this in. I have negative ln, which is right next to 4. The parentheses comes up. What's inside the parentheses? X plus 2. What's on the outside? Plus 3. Alright, now let's graph it. Let's see what it should look like. Alright, good enough. Looks like the letter L, kinda. I'm going to get an easy point. Oh, there we go. -1, 3. If we were confused about our asymptote, what's the first error that we see? -2. It tells us right there. So I'm going to make my dotted line at x is -2. What point did I say it's going to plot? Was it 1, 3? I think it was there. So my graph should look something like this. Oh, -1, 3? Alright, so -1, 3 will be there. Alright, that looks good enough for me. Alright, my transformations, there are 3 of them. What are they? What's the negative tell me to do? Huh? Yep, reflect. What about the +2? Good. We're going left 2. And what about the +3? Nice. Okay. My domain is from left to right. So from left to right, if I move my pen, my graph is not starting to my asymptote, which is -2, and it keeps going towards positive infinity. Remember, for your domain, you're looking left to right. All right, my range is from down to up. For log graphs, my range is going to keep going forever and ever, up and down. So it's going to be -infinity to positive infinity. Let's grab your calculators, look at your y-intercept. For your y-intercept, I'm looking to see where x is 0. Let's just round that. 2.3? 0, 2.3. I'm looking in my table to where x is 0. If you want to write 0, 2, and just estimate, that's fine too, looking at your graph. All right, increasing interval and decreasing interval. From left to right, what are we doing? We're decreasing, right? So what do I write for increasing? None. And I'm decreasing from -infinity to positive infinity. Oh wait, I made a mistake. That's not right. I'm decreasing from my asymptote, which is -2. So I'm decreasing from -2 on to my asymptote. Sorry. Okay, remember when we're looking at decreasing and increasing intervals, always look at your x values. All right, as x approaches positive infinity, this one gets tricky too. All right, that's my right one. Is it going up or is it going down? It was going down, so it's going down towards negative infinity. I know it looks like it's going towards positive infinity, but it's actually going down. So what you have to ask yourself is, am I getting closer to my asymptote or am I going up or down? Okay, not left or right. Any questions on this one? All right, so we have 20 minutes. I think it is best if you use this time to start your homework. If you want to finish number 4 and just practice, I can put the answers up for that in 5 minutes.